Okay guys, so we're gonna be working on our surface area and volume review. Before we get started, we need to make sure we have our supplies. The first thing we wanna make sure we have is our STAR formula chart because we're gonna need them for the surface area and volume section. We're also going to need our calculator. Why do our calculations in our head or by hand and waste time? Because this will take us a while. We also need our review. I also recommend that you get some sort of color pencil or highlighter, something that we can shade in our bases for. You are allowed to use a color pencil on the test, so if you get comfortable using it, they do provide you one on the test. Of course, you need to bubble with pencil, but just something else to identify bases or whatever else we need. So let's go ahead and look at the first question on our surface area and volume review. The first topic we're going to be talking about is the surface area for lateral and total surface area of rectangular prisms, triangular prisms, and cylinders. The first question says, a cylinder and its dimensions are shown in the diagram below. What is the lateral surface area of the cylinder in square centimeters? So we are going to be looking for lateral surface area of a cylinder. So we're going to go ahead and look at our formula chart. Here's surface area, here's lateral. We're not looking at a prism, we're looking at a cylinder, so that's going to be this formula right here. We're going to go ahead and set it up in our table. 2 pi r h. So 2 is just 2, pi is just pi, r is the radius. So we're going to look at our cylinder, and we have two measurements. 8.5, it's telling me from one end of the circle to the other, and then 10.5 from one base to the other. So we're going to go ahead and shade in our base with our color pencil or highlighter or whatever we have. So this is my base. So from one base to the other is 10.5. This is not going to be our radius. Our radius only has to do with our base, the circle. So our circle right here has a radius, but it doesn't give us the radius. Our radius is just from the center to the edge. Instead, it gave us all the way across. So what we're going to do is, with our diameter, we're going to cut that in half or divide by 2. So in our calculator, we're going to type in 8.5 divided by 2, click enter, and we end up with 4.25. So our radius, or r, is 4.25. This is what we're going to use. We have to use our radius because we have r, not the diameter that they gave us. So 4.25. H is the height. Remember, H means the distance from one base to the other. Here's one base, the other one is down here. We can't see it. They're 10.5 apart, so H is 10.5. Then we're going to go ahead and multiply, but we're going to start off by multiplying the numbers that are not pi to get our exact answer. So 2 is not pi. Pi is pi, so we're going to leave that alone. 4.25 and 10.5. So let's go ahead and multiply these three numbers in our calculator. 2 times 4.25 times 10.5, click enter, and we end up with 89.25. So our answer is 89.25. We didn't multiply by pi, so we still have to add it, pi. This is approximately, remember this symbol means approximately, so let's go ahead and do 89.25 times pi. Remember, your pi button is right here next to the H. Go ahead and click that. Enter, enter, 280.387. Now we want to round to our nearest hundredth, so it's going to be 280.3. This is going to round up to 9. 280.39. Let's go ahead and look at our units. We have centimeters, and we're talking about the surface area, which is squared. Now let's go ahead and look at number 2. The rectangular prism and its dimensions are shown in the diagram below. What is the total surface area of the prism in square inches? Now we're going to look for the sides that are parallel. But when we look at a rectangular prism, we notice that these two sides are parallel, the top and bottom are parallel, the front and back are parallel. And since it does not specify, we can choose the one that we want to be the bases. So let's go ahead and pick the easiest ones to look at. We're going to pick the bottom and the top. These two parallel sides are going to be our bases. So let's shade them in. And then we're going to go ahead and actually draw our base. So our base is a rectangle. So we're basically just drawing what we shaded in here with our color pencil. So I'll color it the same color so we know it's the same thing. Okay. So the dimensions of this blue rectangle that we shaded in is 7.2 by 5. So we're going to label our base 7.2 by 5. Now let's go ahead, now that we have our base drawn, let's go ahead and write down our formula. So our formula for total surface area of a prism, surface area total prism, pH plus 2B. So we've been sending it up in our formula. Let's go ahead and do that. P is the perimeter of the base. Well, here's our base. We have 1, 2, 3, 4 sides for our base. So when we find the perimeter, we need to add 4 numbers. But we only have 2 written down here. So we're going to go ahead and label that these 7.2, this one, is the exact same as the one opposite of it. It's also 7.2. And then this one that's 5 is the same as this one over here, 5. So in our calculators, we're going to add 7.2 plus 7.2 plus 5 plus 5. Go ahead and click enter. Those 4 sides of my rectangle give me 24.4. So P is 24.4. H is the height, the distance between our bases. Here's one base, here's the other. This is 6.2. That's why we chose the top and bottom as a basis, because it was easiest for us to see our height that way. When they're in the top and the bottom, they're 6.2 apart. Plus 2 is just 2. Capital B means area of the base. So this area right here. So this shape of our base is a rectangle. We're only looking at our base, only looking at this one. We don't care about any other numbers besides what we identified as our base. So our base is a rectangular parallelogram, so we use BH. So looking at just this, the base is 7.2. The height of that rectangle is 5. So we're going to do base times height, or 7.2 times 5. 7.2 times 5, enter, we get 36. So capital B, which remember is area of the base, is 36. So let's go ahead and multiply them. We have pH here. So they're right next to each other. We're going to multiply them. And then 2B are right next to each other. We're going to multiply those. And then we have a plus between them. We're going to add those results. So 24.4 times 6.2. Enter. We end up with 151.28. So 151.28 plus 2 times 36 is 72. So let's go ahead and add those two together, 151.28 plus 72, and we end up with 233.28. So 233.28, our units are inches, and since we were talking about surface area, it's squared. The triangular prism and its dimensions are shown in the diagram. What is the lateral surface area of the triangular prism in square centimeters? So again, we're going to identify our bases. We're looking for the ones that are parallel. Here we had multiple options. Here we only have one option. So this rectangle right here is not parallel to this one. If we look, they meet right here at this edge. It's not parallel to this one down here. They meet down here at this edge. So we're going to go ahead and shade in our bases, which end up being these two triangles. This triangle right here is directly parallel to this one back here. So we have our two bases. Let's go ahead and draw our base. So here's my base. We have a right triangle, so let's go ahead and draw that right triangle. I'm just redrawing what I have here a little bit smaller. My measurements for this one are 4 here, 3 here, so 3 here. And then this front triangle, this front base doesn't have a measurement for the side, but I know that these two bases are exactly the same. So I'm going to look at the one in the back and see if I have a measurement for this diagonal, this hypotenuse. And I do, it's 5 feet. So I have all my measurements for my base. So we'll keep that, and then we'll deal with those numbers in a second. So we are looking for lateral surface area, which is just PH, right? So we have a triangular prism, surface area of a prism, lateral is just pH. So we're gonna find the perimeter of our triangle. So we have 1, 2, 3 sides of a triangle. We need to add 3 numbers. So 3 plus 4 plus 5. So 3 plus 4 is 7, plus 5 is 12. And then H, the distance between bases. There's one base up here in the front, one base back here in the back. The distance between them ends up being 7 feet, so that's H. So we're gonna go ahead and in our calculator, multiply P and H, or 12 times 7. Let me clear it out so we don't get confused from the other problems. So 12 times 7 and click enter, we get 84. So our lateral surface area is 84. Our units were feet. Again, we're talking about surface area, so squared. A rectangular prisms and its dimensions are shown in the diagram. What is the total surface area of the rectangular prism in square inches? So we're gonna go ahead and again, shade in our bases, top and bottom. Oops, here's my color pencil, top and bottom. Now we can't see the bottom, that's okay. We know that it's this one down here. Let's go ahead and draw that base. It's a really long rectangle. So let's go ahead and look at this measurement. So this one, this length is 22. And then this length right here is 5.5. So we have our base drawn up. We're looking for total, so it's PH plus 2B, where P is the perimeter of the base. So 22 plus 22 plus 5.5 plus 5.5, which is 55. So our perimeter is 55. H, the height, is going to be, okay, here's one base, here's the other. They are 7.5 apart. That's why I want to make the top and bottom the bases. Because if we had made these sides the bases instead, the height, or H, would be how far apart is this side from this side, which would have been 22. So we're making it as easy as possible for us by identifying the top and bottom as our bases. So that way the height happens to be the up and down from one base to another in 7.5. Plus is just plus, 2 is just 2. Capital B, the area of the base. So 22 times 5.5. 22 times 5.5. And we end up with 121. So let's go ahead and multiply what we need to multiply. PH, or 55 times 7.5, and 2B, or 2 times 121. Let's go ahead and make that look more like a 2. So let's go ahead and do that. 55 times 7.5, and we end up with 412.5. 412.5 plus 2 times 121, 242. So let's go ahead and add those together. 412.5 plus 242, and we end up with 654.5. Now let's go ahead and, let's move on. Let's go ahead and look at our units. We have centimeters, and since we were talking about surface area, it's centimeters squared. Number 5, Coach Jocelyn wants to paint his storage shed. He needs to calculate the lateral surface area of the shed so he will know how much paint to buy. The shed is in the shape of a rectangular prism with the dimensions shown below. Including the doors, what is the lateral surface area of the storage shed in square feet? So he's painting it, but he's not painting every surface. He's not painting the bottom. He's not painting the roof up here. He's only painting these 4 sides, which means we're doing less work. We're looking for the lateral, but it even tells us the lateral right here. So we're looking for the lateral. We know this is a rectangular prism. So surface area, prism, lateral, PH. Now here it does specify our bases. Our bases are whatever we're not painting. So we're not going to be painting this top part, the roof, or the floor down here. So those are our bases. We need to find the perimeter of this base right here. So let's go ahead and draw our base. So rectangle like this. So this measurement is 15. This one is 10. So we're going to find our perimeter by adding up all four sides. These sides are going to be the same as these. So 10 plus 10 plus 15 plus 15. We should end up with, let's see, I think it's 50. Yep. So P is 50. H, the distance between our bases, here's one base. The other one's down here. They are 7 feet apart, so H is 7. So we just got to do P times H, or 50 times 7. 50 times 7, 350. So our answer is 350. And we're talking about feet squared. Now let's go ahead and start talking about volume. 8.6a, I can describe the volume formula V equals BH of a cylinder in terms of its base, area, and its height. So question number 6 says, a cylinder and its dimensions are shown in the diagram. Which equation can be used to find V, the volume of the cylinder, in cubic inches? So this time we're looking at just which equation. So we're going to go ahead and write our formula. This is the volume of a cylinder. So we're going to look under volume. Cylinder, V equals BH. Now remember, B is replaceable. It's a capital letter, which we're not used to seeing on the other side of the formula, so we know we have to do something a little bit different with it. So B means area of the base. So let's go ahead and identify our base for this one. Two sides that are parallel. The only option, the two faces that are parallel, the only option is these two circles. So we have one circle down here, that's the base, and the other one up here, that's the base. I know now that my base is the shape of a circle. Capital B is the area of a circle. So under area, we're gonna look under circle, pi r squared. So let's go ahead and rewrite our formula. V equals, and instead of B, we're gonna put our area of a circle formula, pi r squared. So instead of B, we wrote pi r squared, and we still have V equals capital B H. All we did was replace the capital B. So let's go ahead and see what we have. The radius is equal to 3. So V equals pi times the radius is 3, but we do r squared, so 3 squared. H is just still H, so we'll keep it H. Which one matches this? No, it says 3h squared. We didn't square both 3 and the h. 1.5h squared. Nope, we didn't square 1.5. 3 squared times h. Yes. But let's talk about where they got that 1.5. It looks like they got the 3 and cut it in half. Now we don't need to do that because this is already r. The only time that we're going to cut it in half is when it gives us the diameter, or d, instead. But it gave us r. We don't have to change it at all. It stays 3 squared. So here they did cut it in half, but that wasn't what they were supposed to do, so it ends up being C. Go ahead and look at the next one, number 7. It says a hat box in the shape of a cylinder is modeled below. The diameter of the cylinder is 20 inches. The height of the cylinder is 5 inches. The volume of the cylinder can be found by using the formula V equals BH. Which expression can be used to determine B, the area of the base of this hat box, in square inches? So we're not even looking for the volume. We're set to determine B. We're looking for capital B. Well, we talked about seeing how we're supposed to identify capital B. We got to identify our bases. So we have a cylinder here. We're looking for the two parallel faces. The only option are these two circles. Here's one face. The other one is down here that we cannot see it. Okay? So these are our two bases. This shape right here is a circle. It's always a circle for a cylinder. So we're going to look at volume of the cylinder, V equals BH, or we can go back to our problem, V equals BH. So V equals BH. But we want to replace B with the area of a circle since we have a circle for the base. So V equals, we're going to look at the area of a circle, pi r squared. Pi r squared is our replacement for B. Now it said just which can be used for capital B, so just the red part is what we're focusing on. Pi r squared. So let's go ahead and look at it. So we have pi times the radius. Now it didn't give us our radius, instead it gave us our diameter. Here's one end of the circle to the other end, all the way across, and we know our radius should just be from the center to the edge. So we're going to take our diameter, which is what they gave us, and cut it in half. So the radius is actually 10. So to cut it in half in our calculator, we're just going to do 20 divided by 2, and we end up with 10. So where it says r squared, we're going to not plug in 20 because that's d, we're going to plug in r, 10. 10 squared. Now we were just looking for b, so we're going to stop there and see which one matches that. 10 squared times pi. Yes, they just flipped them. 20 squared times pi. Nope. We know that 20 is the diameter, which doesn't go in our formula. R goes in our formula. 20 squared times 5. Nope, that's including h, and it asks us to find b. And it doesn't even include pi like we need it to. For 10 squared times 5. Also doesn't include pi. Also includes height. When it said the height was 5 inches, we're not using that. We're just focusing on the B part, that red part that we're using. So our answer has to be A. 8.6b, I can model the relationship between the volume of a cylinder and cone with congruent bases and heights. Look at the figures below. Which statement correctly describes the volumes of the two figures? So we have a cone here with a radius of 3 and a height of 7. Then we have a cylinder with that exact same dimensions. The radius is 3 and the height is 7. So they have the exact same bases. This base right here is completely equal to this base right here. Well, that looks like an awful lot like that video that we saw in class where we had this filled up with popcorn, and then we filled up and said how many cones we could have. So we saw that 3 cones was equal to 1 cylinder when their bases were exactly the same. So the volumes are the same. Not true. I know that the volumes were different. What this could hold was different from what this could hold. One of these could hold 3 of these. The volumes are the same because the dimensions are the same. Nope. So the area of the bases are the same, but the volumes are not the same. We want the whole statement to be true. The volumes are the same because the dimensions are the same. Yes, the dimensions are the same, but the volumes are not the same. We know that this one holds more. The volume of the cone is 1/3 greater than the volume of the cylinder. Is the volume of the cone greater than the volume of the cylinder? No. The volume of the cone is 1/3 the volume of the cylinder. Yes, one cone is equal to just 1 part of this cylinder, just like 1/3 of it. So D is true. 8.7a, I can solve problems using volume of cylinders, cones, and spheres. The cone and its dimensions are shown in the diagram. What is the volume of the cone in cubic inches? So we have volume of a pyramid or cone. We're looking at cones, so let's look at this one. 1/3 BH. So we have V equals 1/3 BH, where B needs to be replaced by the area of the base. So we're going to go ahead and identify our base for the cone. What do you know? It's a circle, just like we were doing earlier with the cylinders. So we're going to write V equals 1/3. Instead of B, we're going to put the formula for the area of a circle, which is pi r squared. H is the height from the vertex to that base. So let's go ahead and plug in our numbers. So we have V equals 1/3. Pi is just pi. R is our radius. So our radius is from the center to the edge, which we don't have. Instead, it gave us from one edge all the way across to the other edge. So we're going to get our diameter D and cut it in half, divided by 2. So when we type in our calculator, 3.5 divided by 2, we end up with 1.75. So R is 1.75. So 1.75 squared, and then h, the distance between our center to the vertex, is 4. Let's go ahead and type that in. Now we're going to start off by multiplying our numbers that are not pi. So we have 1/3, 1.75 squared, and 4. Let me clear it out again, menu 1/5. Control divide brings up our fraction. So 1/3, click right to get out of your fraction, times, we're going to skip the pi 4 now, and do 1.75 squared. Remember, our squared button's right here next to the 4. And then times 4. Click enter. I ended up with 6.083 repeating, but we're going to round it to the nearest hundredth, so 4.08. Pi, because we didn't multiply by pi yet, is approximately, and now we are going to do 4.08 times pi. 12.8, that 7 rounds it up to 12.82. Our units are inches. We're talking about volume, so it's inches cubed. Try to be as accurate as possible. We do have a pi button. Make sure you're using your pi button instead of just using 3.14. Also, if you get your test, make sure that you're picking the closest one. If 12.79 is the answer choice and you got 12.82, that is extremely close. It's only 0.03 off. So make sure that you choose that one. Pick the closest one. Now, though it was like 9 was the option, that's way different. Let's go ahead and look at this one. A ball is shaped like a sphere, so I know the shape of the solid, and has a radius of 3.5 centimeters. So I also know the radius. What is the volume of the ball in cubic centimeters? So volume, sphere, 4/3 pi r cubed. The only number that I need to use this formula is r, so the radius. V equals 4/3 pi r cubed. So let's go ahead and write that. 4/3 times pi times the radius here is 3.5. It tells us it's the radius, but we also see it's from the center to the edge. So 3.5 cubed. Let's go ahead and type that in. Okay, so control divide brings up our fraction. 4/3 times, and then we're just going to multiply 3.5 cubed. We're going to skip pi for now. 3.5. Remember, for cubed, we use our caret button. Excuse me. We use our caret button, which is right here, and we want our exponent to be 3. So times 3.5 cubed. Click enter. We ended up with 57.16 repeating, but we're going to round that to 0.17. So we have 57.17 pi, because we haven't multiplied by pi, which is approximately, so 57.17 times, here's our pi button, we get 179.6, that 5 rounds it up to a 1. What units were we talking about? Centimeters, and then we're talking about volume, so cubed. So this is our answer. Number 12, a storage container for oil is in the shape of a cylinder. with a diameter of 20 feet and a height of 15 feet. What is the volume of the storage container in cubic feet? So volume. Remember, another word for volume is capacity. So if it instead said, what is the capacity, then we would know that we're still looking for volume. Okay, so it has a diameter of 10 feet. So we're going to go ahead and identify our base. It's a cylinder. We know our base is a circle by now for all cylinders. Shade that in. We know the diameter is 20. Diameter only talks about circles. So from here to here is 20. And the height of 15. So from here to here is 15. Okay. Let's make it accurate with our units. So let's go ahead and see. We're talking about the volume of a cylinder. V equals BH. Hey, we've been using this formula already. And we know our base is a circle. We shaded it in. I know it's hard to see, but we know capital B is a circle. So it's going to be V equals pi r squared instead of B. So that's what it'll look like. To use this formula, we need the radius and the height. Radius. Didn't give us our radius. It gave us from one point to another the diameter. So we're going to cut that in half. So our radius is 10. Our height from one base to the other is 15. So V equals pi is just pi. Our radius is going to be 10 squared. H is 15. So let's go ahead and multiply numbers that are not pi, 10 squared and 15. So 100 times 15 should be 1,500 pi. And this is our exact answer. Remember, the ones that are actually with pi are our exact answer. So we're going to also do our approximate answer where we actually do 1,500 times pi. Remember, our pi button is down here next to the H. Click enter, and we end up with 472.39. Oh, I'm sorry. It's actually 4,712. Missing that number right there. There we go. 4,712.39. This is our approximate. What units were we talking about? Feet. And then cube, because we were talking about volume. There we go. Mrs. Plummer used a container shaped like a cylinder to catch rainwater. The dimensions of the container are shown below. What is the volume of the container in cubic centimeters? So again, volume, another cylinder, so we're using our same exact formula. V equals BH. Gotta identify our base. Hey, it's a cylinder. We know that means our base is a circle. Or should I say circle, since we have two of them. Okay. So let's go ahead and replace B with our circle, area of a circle formula, pi r squared times h. So let's go ahead and plug it in. V equals pi is just pi. Our radius from the center to the edge, right here. So this is our radius, not our diameter. It doesn't go all the way across, so we do not need to divide it. It stays 4.9. So 4.9 squared. H from one base to another is 7.8 feet apart. So let's go ahead and multiply the numbers that are not pi first. 4.9 squared and 7.8. So 4.9 squared times 7.8. And we end up with 187.28, because that 7's going to round up. 187.28 pi, because we haven't multiplied by pi yet. Is approximately, now we are going to do 187.28 times pi. we end up with 588.36. 588.36. Our units were feet cubed because we were talking about volume. And that's it. Make sure y'all guys are ready for your test tomorrow. So that way y'all guys can all get good grades like I know you will.